Hello, welcome. We provide a solution to this nice exponential equation. So what's the value of x? Solution. Now, as you can see, 3 raised to power x plus 1 plus 3 raised to power x minus 1 is equal to 48. So x plus 1 can be expressed in the form of x, okay, x minus 1 plus 2, okay? So we can express x plus 1 as x minus 1 plus 2, okay? So let's substitute x plus 1 with x minus 1 plus 2, so that we're going to have 3 raised to power x minus 1 plus 2 plus 3 raised to power x minus 1. This is supposed to give us 48, okay? So if you do that, if you check, 3 raised to power x minus 1 plus 2 is in the form of a raised to power n plus m, which we can express as a raised to power n multiplied by a raised to power m. Okay? Now, we're going to have 3 raised to power x minus 1 multiplied by 3 raised to power 2 plus 3 raised to power x minus 1. This is equal to 48. Okay? And as you can see, 3 raised to power x minus 1 is common. So we factor out 3 raised to power x minus 1. So you'll have 3 raised to power x minus 1 into the bracket. This is 3 squared plus 1. This is equal to 48. Okay? So that you'll have 3 raised to power x minus 1 multiplied by, now this is 3 squared, which is 9, plus 1, which is equal to 10. This is equal to 48. Okay? So we divide both signs. We divide both signs by 10. Okay? So that we'll have 3 raised to power x minus 1. This is equal to, we simplify. If you say 48 divided by 2, this is 24. Okay? So we'll have 24 divided by 5. Okay? Now, so for the value of x, we introduce the natural logarithm as follows. We'll have log 3 raised to power x minus 1. This is equal to log 24 divided by 5. Okay? So now, applying the logarithm power rule, that states that if you have log m raised to power p, this can be expressed as log, that is p log m. Okay? So let's apply this identity so that we'll have x minus 1 log 3. This is equal to log 24 divided by 5. Okay? So we have x minus 1 log 3 is equal to log 24 divided by 5. Okay? So applying the second identity for logarithm, so if you have log a divided by b, this can be expressed as log a subtract log b. Okay, so we can apply this identity so that we can express this as x minus 1 log 3. This is equal to log 24 subtract log 5. Okay, so we divide both signs by log 3, and also this side by log 3. So now we will have x minus 1. This is equal to, now as you can see, 24 can be expressed as 8 multiplied by 3. Okay, so this shows that we can have log 8 multiplied by 3, okay, divided by log 3 subtract log 5 divided by log 3. Okay, now let's proceed. Again, if we have log a multiplied by b, this can be expressed as log a plus log b. Okay, so let's apply this identity so that we're going to have x subtract 1. This is equal to log 3, okay, divided by log 3 plus log 8 divided by log 3, subtract log 5 divided by log 3. All right. So as you can see, we'll have x minus 1. This is equal to log 3 and log 3 simplifies. You'll have 1 plus log 8 divided by log 3, subtract log 5 divided by log 3. All right. So from here, if you have log, that is log 8 divided by log 3 is in the form of log a divided by log b, which you can express as log a to base b. All right. Now from here, I think that log 8 divided by log 3 and log 5 divided by log 3 is in the form of log a divided by log b, which you can express as log a to base b. Okay. So that means x minus 1, this is equal to 1 plus log 8 to base 3, subtract log 5 to base 3. Okay, so to get the value of x is equal to, we just take this negative 1 on the right hand side, so that we're going to have 1 plus 1 plus log 8 to base 3, subtract log 5 to base 3. Okay, now that means that x is equal to 2 plus log 8 to base 3, subtract log 5 to base 3. This is the value of, that's the value of x. So let's verify if this value of x satisfies the equation. Let's verify if this value of x satisfies the equation. All right. Now, if you recall, we're supposed to have that is 3. Okay, that is 3 raised to power x minus 1. This is supposed to give us a value of 24 divided by 5. Supposed to give us a value of 24 divided by 5. Okay, so let's substitute the value of x. We'll have 3 raised to power 2 plus log 8 to base 3, subtract log 5 to base 3 minus 1. This is supposed to give us a value of 24 divided by 5. Okay, so let's proceed. From here, we have 2 subtract 1. We're going to have 3 raised to power 1 plus log 8 to base 3, subtract log 5 to base 3. This is supposed to give us a value of 24 divided by 5. All right. Now from here, we have that 3 raised to power 1 plus log 8 to base 3, subtract log 5 to base 3 is in the form of a raised to power n, subtract m, which you can express as a raised to power n divided by a raised to power m. All right. So you're going to have 3 raised to power 1, okay, multiplied by 3 raised to power log 8 to base 3 divided by 3 raised to power log 5 to base 3. This is supposed to give us a value of 24 divided by 5. Okay, so let's see how it goes. For instance, if you're given m raised to power log b to base m, this can be essentially give you a value of b. Okay, so let's apply this approach so that you're going to have 3 log 8 to base 3. This is supposed to give us a value of 8. And for the case where you have 3 raised to power log 5 to base 3, this is supposed to give us a value of 5. Okay, so now we substitute. Okay, we substitute the values of 8 and 5, so that we're going to have 3 raised to power 1 multiplied by 8 divided by 5. This is supposed to give us 24 divided by 5, okay? So that you say 3 times 8, this is 24, divided by 5 is equal to 24 divided by 5. You can see clearly that the left-hand side is equal to the right-hand side, okay? And that affirms that the value of x, which is given as x is equal to 2 plus log 5 to base 3 minus log 5 to base 3 satisfies the equation, okay? Thank you for watching and kindly consider subscribing. Thank you.